Okay, so what we're trying to do here is we're trying to find the area enclosed by the ellipse. So first we start with x squared over a squared plus y squared over b squared equals 1. So the first step is we are going to move over the x squared over a squared to the other side, to the right side. And ultimately we want to find the y by itself. So we want everything on this side to move over. So we're going to start with moving over the x squared over a squared. So we end up with y squared over b squared equals 1 minus x squared over a squared. And so to simplify that and put these together, we make the 1, it's pretty much this, the 1 can be the same denominator as the other one. So we end up making that a squared over a squared. So when we combine it, it's a squared minus x squared over a squared. And so what we do here is we are going to multiply the b squared on both sides to get rid of it and get y by itself. So when we bring that over, and also we end up squaring both sides to get y by itself to get rid of the y squared, we end up squaring this side over here. So it's y equals plus or minus b over a square root of a squared minus x squared. And so the second step would be we take 1/4 of the area. So that means we're doing one section, and we only really need one section and we want the positive side. So that's why we do the 1/4. So the 1/4 area equals the integral from 0 to a, b over a square root of a squared minus x squared dx. So what we need to do here is we need to find out what our x is and dx, and we go ahead and we write out what our x squared would be. So we do the x equals a sine theta. And so the dx of that is, which is you're taking the derivative. So you take the derivative equal a, and the derivative of sine is cosine, and then you keep theta. And so since we know our x now, since we know that our x is this, we're going to go ahead and take our x squared, which you end up, since these are like multiplying each other, you apply the square on both of those. So a squared sine squared theta. And what we do is we go ahead and we take our x. So since we know our x equals a sine theta, when you put that on the triangle, this right here, since sine is equal to, was it opposite over hypotenuse. So the x is over a, and then you plug in the Pythagorean theorem, so you get the square root of a squared minus x squared. And so now what since we have that, we have the bottom part of it. Now we can plug in our x squared right here. So when you plug in your x squared, then it goes into here, which is square root of a squared minus a squared sine squared theta. And then you take under here, under the root, since these are both common with a squared, you can go ahead and take the a squared out, and then you get 1 minus sine squared theta. See, this a right here is that 1. that's pretty much what you're doing to simplify it a little more. So now, since we know, since this is 1 minus sine squared theta, we can go ahead and plug it in. We plug in, I guess, yeah, you rewrite it. Instead of this, you rewrite it as square root of a squared cosine squared theta. And so what that means is it equals the a absolute value of cosine theta equals a cosine theta. You don't have to always do the absolute. You just do it like that because we know it's positive. So the fourth step is we change the limit of integration. By changing the limit, it'll give us a way to take the integral. So we start by taking x and you equal that to 0. So that way, that's how you're changing the limit. Is you're going from 0, you're taking the x and equaling it to 0, and you're gonna and then you're also gonna take the x and equal it to a, versus up here we had well, it's a little different than that one. So what we do is we take the sine theta, and you're solving for sine theta now. So here we were solving for x. Here we're going to solve for sine theta. So you take the a and you divide both sides. And so, or you divide it, you equal that to 0. So that equals 0. And that means that theta equal to 0 also. And then when x equals a, sine theta equals a over a, which is the same thing as equaling to 1. And when you plug that in to theta, the sine of 1 is equal to pi over 2. You take that from the unit circle. So now what we're going to do is we're going to take sine. You're going to plug in theta for sine. So sine pi over 2 is equal to 1. So it's the same thing.
Excuse me.
Bless you.
Thank you.
So we take a and we equal that to 4 b over a. And then you take the integral from 0, which 0 here, and pi over 2. Pi over 2 here. And then you're gonna plug in the function, which is a cosine theta times a cosine theta d theta. And what that's doing is you're gonna make it even. So when you do the 4 b over a, you take an a squared out of these when you combine them. So you take that a squared because it's almost like a constant, and you bring it outside of the integral, and then you bring it to 0 pi over 2. And then now all we're left is with cosine squared theta d theta. And since this is even, we can go ahead and we combine these. So this is a squared over a. So this ends up being, they cancel out. The denominators cancel out. So we're left with 4ab, the integral of 0 to pi over 2, cosine squared theta d theta. So we're kind of taking it step by step. And so now we take a 1/2 because we're going to apply the half angle. So we still remain with the 4ab, but now we have a half on the outside of the integral. We move that over, and we have our integral 0 pi over 2 And this is part of the other part of the half angle, which is 1 minus cosine 2 theta. Instead of an exponent, we have a 2 d theta. And so we take this 1/2 and we multiply it times the 4, and you get 2ab. And see, now we're going to evaluate both the inside right here. So when you do that, you end up with theta being evaluated from 0 to pi over 2 plus 1/2 sine 2 theta evaluated to 0 to pi over 2. And then we're going to use substitution. So when we do that, we substitute it back. We end up with, we equal 2ab. And when you evaluate this first one, you get pi over 2. And when you do the second one, you end up with 0. And so you add that, and the lower part is 0, so it ends up just being 0. So we're left with 2ab times the remainder here, which is pi over 2. Multiply them together, the 2's cancel out, and we are equal ab theta. AB pi, yeah. And that's it. Thank you for watching.